All right, so section 2.4, one-sided limits. So the question we have is number 5. So number 5 gives us this cool-looking function here. They even give us this picture as well. So number 5 says f of x is equal to 0 when x is less than or equal to 0, and it's 1 over the sine of x when x is greater than 0. And when you look at this function, you kind of see what they're trying to pull off here. Now, what we know is that, bless you. Remember the number inside messes with its period? Is that clear? Like if this was the sine of 3x, what you're going to do is you're going to take that sine function, you're going to squish it by 3, right? So it means it goes up and down a lot more, right? 3 times as many as the original graph. So when I have this 1 over x here, this inside part is getting, well, it's kind of being manipulated so that what happens is, as I get closer and closer to this x value, these the frequency, the distance between these, one cycle gets closer and closer and closer. So it's going to get really tight here. So they didn't do a very great job of doing the picture. That's okay. Can you guys see it's getting tighter? Okay. So there's no way it exists. So let's talk about the questions. It says, does the limit as x approaches 0 from the positive side exist? So as I go to 0 from this direction, I'm going to do a little better picture. Well, we'll see. So number 5, what we have is it says we have the function is 0 if it's less than or equal to 0. And this is 1 over x. So what happens is as we get closer, so this is this side right here is going to be y is equal to the sine of 1 over x. That's going to be this side. And this side is y is equal to 0. That's our piecewise function, right? So it's separated here. So it looks like a sine function, so it's going to bounce between -1 and 1. But as I get closer and closer to that x-axis, what's going to happen is this thing is going to get tighter and tighter and tighter, 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 and tighter, and tighter. Is that clear? That's what's going to happen there? Okay, so can you tell me the limit from this direction? Do you guys know it? I don't. You guys agree that it's going to bounce between... All I know is that the y value is going to be somewhere between -1 and 1. You guys agree? It's going to be somewhere between this range and this range, where this is 1 and this is -1. Do you know where it stops? Nobody knows where it stops, okay? Because this is going on for infinity, right? Does that make sense? Okay. So this does not exist. Because I can't nail down a point from this direction, right? Good. Another one to ask, what about the limit from the left, though, does exist, doesn't it? What about the limit as x approaches 0 from the left-hand side of f of x? Well, if I'm on this line, what y value am I approaching? Yeah, that one's equal to 0, right? Because its y value is 0. So on this side, it's this 0. This side, it does not exist. So does the limit exist? Does the limit as x approaches 0 of f of x exist?
No.
No, this does not exist because for them to exist, you guys agree they both have to exist and they have to be equal? Does that make sense? So your right hand and your left hand limit have to exist and they have to be equal. So since that doesn't exist, the limit doesn't exist. Number 7 says, number 7 gives us this piecewise function. It says, I'll write it out. F of x is equal to, it's x cubed when x is not equal to 1. And then it's 0 when x equals 1. So if I was going to do a picture of that graph, what I know is at 1, x equals 1 is the only value that's different, right? So x cubed everywhere but 1. So x cubed looks like this. Except at 1, it's not x cubed. Do you guys agree? So we have that function there. What is it at? What's the y value at 1, though? What's the y value at 1? Yeah, the y value is 0. So this is the point 1 comma 0. X comma y. So this is the point 1 comma 0. Does that make sense? Okay, let's talk about the limits. So it wants us to find the limit from the left and from the right. So what's the limit as x approaches 0 from the left of this f of x? From this direction, what's it going to? What's this y value? Yeah, because if you plug in 1 here, guys agree if you plug in 1 into this function, you get 1 back? This has a whole, so this is clearly 1, isn't it? Okay.
As it approaches 1?
Yeah, as x gets close to 1, y is going to be close to 1.
Okay, you put as it approaches 0.
Oh, I did. Thank you. Nice catch. As I approach 1 from the left, yep, of f of x is going to be equal to 1, right? So what I mean by that, this 1 is this one right here, right? And then this one is this one. Okay, so as I approach from this side, I'm going to 1. As I approach from this side, I'm also going to what? I'm also going to 1. So does the limit exist?
No.
Yeah. Because for the limit to exist, the left and right have to be the same. I mean, they have to exist and they have to be equal. Nine. At what points does the right-hand limit exist, but the left-hand not?
Before you move on,
Sure, buddy.
if you wanted us to write that out, would we just write the limit as x approaches 1 from the negative side equals the limit as x approaches from the positive side?
Oh, I see. You want proof of this? Yeah.
Well, I'm just asking, like, because it says if so, what is, if not?
Yeah,
what not?
because you're right. Yeah.
Would
So,
we just write that the limits equal each other, or?
yeah, I would say that the limit exists because, like you said, the limit as x approaches 1 from the right of f of x is equal to 1, which is also equal to the limit as x approaches 1 from the right of f of x. That the two limits are equal and they exist. I know I'm saying it in words, but I do that to save time, but it's probably useful if you guys know what to write on a test. So call me on it if you're unsure, all right? If you're not sure what you want written on a test, just let me know. All right, so number 9, it asks these limits. 1 minus x squared, that's a circle. From 0 to 1, it's a semicircle. It's going to be 1, and it's going to be 2. I'm graphing it. So you guys might not know what these things look like, but I'm going to kind of show you. So for number 9, and it's kind of helpful to know the picture so that I can kind of explain to you why this is actually working. But what I have is I have the square root of 1 minus x squared, and this is from 0 less than or equal to x less than 1. And then it's 1 when from 1 less than or equal to x less than 2. And then it's 2 when x is equal to 2. So a quick question. Just a little side note here, just so you guys know. What's just this piece equal to? If I say y is equal to 1 minus x squared, what is that a graph of? If I say y is equal to the square root of 1 minus x squared. Bless you. What I'm going to do is I'm going to put this in implicit form because maybe you guys will see it. You guys have dealt with circles before, right?
A long time ago.
I know, so that's why I'm going to bring it up, okay? That's why we're talking about it now. So what I'm going to do is I'm going to square both sides. Y squared would be equal to 1 minus x squared. Then when I send that x squared over, I'm going to have x squared plus y squared is equal to 1, right? Now, if you guys remember the equation of a circle, if the center is h comma k, and the radius is, well, the radius, let's just say the radius is equal to r, and then our equation of a circle would be x minus h squared plus y minus k squared equals r squared. We actually did it in pre-calc. We had like one question on it. It was way back in chapter 1. So can you tell that this circle right here is centered at, there's no h or k, right? So that means h and k have to be 0, right? And then what I do, I'd have to square root this number right here to find its radius. What's the square root of 1? 1, okay. So this is centered at 0, 0 with a radius of 1. So this circle is centered at 0, 0. Technically, I shouldn't have put a point there. It's not, that's not part of the graph, okay? That's just its center. That's 0, 0. But it's got a radius of 1. So it's going to look like the black is going to be this function, okay? Yeah, pretend it's a circle. That's what it looks like, right? Okay, so now let's go back to what we have here. It says that we're going to be this circle in between 0 and 1. Now, we have to be careful here. Is this thing a function? Okay, so let's a little more talk about this. So if I have x squared plus y squared is equal to 1, if I want to turn this into a function, I have to solve it for y, right? So I'm going to kind of go backwards. So if solving for y, I'd have y squared is equal to 1 minus x squared. And then I'd have to square root both sides, right? When you square both sides, what do you always get when you square root both sides? Yeah, plus or minus to 1 minus x squared. So the positive version is the top half of the circle, and the negative version is the bottom half of the circle. So since they're asking for this, just positive 1 minus x squared, they're actually only talking about the top half of the circle. Because remember, this has to be a function, so it has to pass the vertical line test. So that's honestly just a reminder. You guys might not have seen circles in a while, so I just want you guys to be familiar. They come up later and later in the course. All right, so what I have here, looking at this graph, the graph goes from 0 to 2, right? So that's all I have to graph. I have to go to 0, 1, and 2. That's the domain of the function, right? I know that it's the top half of the circle, but only from 0 to 1. So for this function, it's going to start at 1. I'll do it in red. So it's going to be closed circle, and then at 1, it's going to be an open circle. That's that circle right here, right? The top half from 0 to 1. And then I have y is equal to 1 from 1 to 2. So y is equal to 1. So close that 1. Y is equal to 1, right? Y is equal to 1. So this is going to be y is equal to 1 from 1 to 2. Open. And then I have y is equal to 2. Dang it, I'm out of room. Oh well, here we go. There's 2. So then I have y is equal to 2. Oh, that's cool. What does this mean? Y equals 2 and x equals 2. How many points are on this line? You guys agree? So when x is equal to 2, y is equal to? So this is just the point 2 comma 2, right? Okay, so this is the point 2 comma 2. Alright, now let's talk about some limits. So they ask for, they want to know all the points. What's the domain of the range of the function? What's the domain of f? You guys agree the domain of f is everywhere from 0 to 2? Okay, so this is going to go close 0 to close 2. There's an x value for every one of these, right? The range? Well, it goes from 0 to 1, open from 0 to 1 closed, right? But then I also have to union this single point of a 2, right? So this 2 is discrete, that's why it has the squigglies around it. Because there's only a single point, right? So that'd be the shadow onto the y-axis.
What about that pole on the y-axis?
This one right here?
The I thought I see a pole on the y-axis.
That's a 0.
The 0 mark.
Oh, I see. I got you. Yep, you're right. Thank you. I was confused. So, domain and range. What points, if any, does the limit exist? And I think they're asking for integer values. So I think they're only asking about 1, 2, and 3. So, is that what it's asking, or is it asking for a? It's asking for an interval. I just want to know. Because the limit would actually exist on any open interval containing this domain. So the limit would exist from 0 to 2 open. But I'm not sure if that's what they're asking. They might just be asking for the integer value. So let me go back into the solution and make sure that we give you the answer they're looking for. 2.4. Do they want numbers or do they want an interval? Yes, okay. Whoa. They gotta be careful with that. I don't agree. Oh no, that's the domain. I got that. So, okay. They want an interval. Okay, good. So, for B, they want to know where does the limit exist? What's the only number in between 0 and 2 that the limit will fail at? You guys agree? Because the limit from the left and the limit from the right will be different. Now, I don't like the endpoints. They include the endpoints, but I'm not sure I like that. Because this has a limit from the right. Like this point right here has a limit from the right, but it doesn't have a limit from the left. You guys agree? So I don't want to include it. I know they do, and it bothers me, okay? This one has a limit from the left, but doesn't have a limit from the right. You guys agree? So this is what I'm writing, and the heck with them. So this goes from 0 to 1, right? Anywhere on this open interval, it's going to have a limit, right? Now I have to exclude this 1 because the limit from the left is 0, but the limit from the right is 1, right? So 1 is not included in a place that has a limit. And also I go from 1 to 2. I think the book includes 1, but I don't agree. Because the limit from the left has to equal the limit from the right. It doesn't have a left-hand limit. All right. Let's see. At what points does the left-hand limit exist, but not the right-hand limit? Oh, that's good. So this is the question I kind of was getting to. So what has a left-hand limit, but not a right-hand limit? Remember, it doesn't exist. Yeah, a left-hand limit means coming from the left. So as I come from the left, so I guess one point right here would be in suspect. You guys agree? So this point, because it jumps, we know that has a left-hand limit, and that left-hand limit is 0, right? Does this point also have a right-hand limit? Does x equals 1 have a right-hand limit? Yes. What's its right-hand limit? 1. So from the left it's 0, but from the right it's 1. So it does have both limits, right? Doesn't mean they're equal, but it does have a limit from both directions, doesn't it? Okay, so the ones that really would have a limit from one direction but not the other are going to be these endpoints here. Is that clear? Really, these values. Is that clear? Now 2 has a limit from what direction? From the left, but not from the right. I think that's what they're asking. What has a left-hand limit but not a right-hand limit? So C is going to be x is equal to 2. That has a limit from the left, and that limit from the left is 1, right? So the limit as x approaches 2 from the left-hand side of f of x is equal to 1. It exists, doesn't it? Now, I bet you D is the other one. What has a right-hand limit but not a left-hand? So this point right here has a right-hand limit. You guys agree? Because it goes to what? Okay. So I would say it's x equals 0, and this is because the limit as x approaches 0 from the positive direction of f of x is equal to 1. But it doesn't have a right-hand limit. I mean, left-hand limit. You guys agree? Because to have a left-hand limit, you have to have a function over there. You need a road to drive on, right? Okay. That was a long one. All right, so number... If I'm ever out of frame, you guys let me know, okay? 15 says the limit as h approaches 0 from the positive, I'm getting blind, from the positive side of the square root of h squared plus 4h plus 5 minus the square root of 5 all over h. I'm falling apart, man. That's what's happening. Don't get old. I guess it's better than the alternative. Get old. So, things that we concern ourselves with are, when it comes to things that have like a left-hand limit and a right-hand limit, do you guys agree that we have to really identify the things that could be different from two different directions? So things that are different from two different directions that we have to pay attention to are like radicals. Like a square root function is like a one-sided function, right? So if I have y is equal to the square root of x, say plus 4 minus 2, what I know is it's going to go left 4 and down 2, right? So I'm going to have a function that looks like this. So this will have a right-hand limit but not a left-hand limit, right? So the right-hand limit would be equal to -2, but its left-hand limit does not exist. Other things we have to be careful of is if f of x is a piecewise function. Like f of x might be x plus 1 when x is less than 1, and 2x when x is greater than or equal to 1, right? So a function like that would, it would be x plus 1 would look like this, right? Until I get to 1. It's supposed to be 1 there. And then I'd have 2x, which should be something like that. You guys agree? So this is going to have a left-hand limit, it's going to have a right-hand limit, but those limits are not going to be the same, are they? So these are the things we have to be careful of. Now everything else, like the functions that you saw before, like what if I have a function that looks like this? What if I have a function that simply just has a hole? I don't really care about its shape. Yeah, the left-hand limit, the right-hand limit are the same. This thing has a regular limit, right? So it doesn't matter if I'm asking for a left or right-hand limit. The way you apply the limit is the same way you did in 2.2. So that sense, you just simplify the function and plug it in. So what I'm wondering is if that h cancels. If the h cancels, it's a hole. That just means I just applied the limit like I did before. How do you simplify this expression here? How do you take care of radicals?
Conjugate.
Conjugate. So what's the conjugate to something minus something? Okay. Top and bottom. Now what am I going to multiply together? The tops or the bottoms? Why? Yeah, you multiply the tops because those are the conjugates, right? And conjugates multiply nicely, don't they? So always multiply the conjugates together, but not the ones that are not. So this is going to be the limit as h approaches 0 of let's multiply the tops. So when I do first, root something times root something is just that something, right? Because the radical is going to cancel. So this is h squared plus 4h plus 5. Now what's nice about conjugates is that outside and inside are always going to be opposite of each other, right? Outside is plus the multiplication of these two things. Inside is minus the multiplication of those exact same two things, right? So they're going to cancel. I'm not writing it, okay? So outside and inside will cancel. So then we do last. Well, negative root 5 times positive root 5 is going to be negative, right? And root 5 times root 5 is 5. And then again, we leave the bottoms alone. They are not conjugates, so do not multiply them together. Now what I'm hoping is when I simplify, I can cancel this h right here, right? So let's clean up the numerator. Does anything cancel the numerator? Fives go away. And now, look at that. Everything in the numerator has a what? Has an h. So that means I can factor that h out and cancel it. So canceling those h's. You guys agree right now I can plug in h equals 0? I couldn't do it because of this thing right here, right? But now that I canceled, we're good. So plugging in h equals 0, this will be equal to 0 plus 4 all over the square root of 0 squared plus 4 times 0 plus 5 all into the radical minus root 5. So the numerator is going to be 4. This is going to be root 5. Oop, this should be a plus. I apologize. This comes from this plus sign right here. Plus. Plus root 5. So what I get is 4 over, well, 2 root 5. And then finally 4 goes into 2 twice. So this is 2 over root 5. That's our answer. No, you add them together. Like an apple plus an apple is how many apples?
2 apples.
Does that make sense? So if you have root 5 plus root 5, you're going to have 2 of those root 5s.
Okay, yeah, I get it.
Kind of like x plus x is 2x. 15. Yes, no.
Do 1A.
Let me do one. Let me do one more of these because if you want to see number 1, we'll do it after that because it's very similar to what I did a bunch of pictures already. I have enough time for maybe 1 or 2 more problems, and I want to get to ones that we have to algebraically simplify. So the last one I'm going to do is going to be number 17. I got 2 sections to do. Okay, I'll give you guys 2 more. Number 17, I'm going to have to kind of cruise a little bit. So number 17 says that we have the limit as x approaches negative 2 from the positive direction of x plus 3 times the absolute value of x plus 2 all over x plus 2. So you guys notice that what makes 17 difficult is this absolute value thing. All right, so let's kind of investigate what that absolute value thing is. I'm going to do it down here, and we'll come back and simplify it. Well, the absolute value of x plus 2, we already discussed. It's negative this x plus 2 if x plus 2 is negative, right? And it's equal to itself if x plus 2 is greater than or equal to 0, right? So what I can do is I can simplify this piece over here. So it would be negative the x plus 2 if x is less than negative 2, and it's equal to x plus 2 if x is greater than or equal to negative 2. So when I look at this expression here, what I want to know is what am I going to replace this piece with? Is it going to be this top one, or is it going to be the bottom one? What one goes there? Is it the negative of itself or the positive of itself? Well, we have to look at the limit.
Oh, it's gonna
Look at this number here. Am I above 2 or below 2?
Well,
My bad. I said that wrong. It's negative 2 that we're looking at, right? So am I bigger than negative 2 or am I smaller than negative 2? Look at the plus sign. What direction am I coming from? So here's negative 2 right here. What direction am I coming from if it's positive?
right.
The right. So that means I am bigger. Okay, so here we are. I'm bigger. I'm this one, aren't I? Does that make sense? So the plus sign tells me what function I'm going to use. So that means I'm not replacing it with the black. I'm replacing this thing with the red one, aren't I? So that means I'm using this one right here, isn't it? So plugging it in, so now we can simplify. This is going to be the limit as x approaches negative 2 from the positive side of x plus 3. This thing becomes just x plus 2 all over x plus 2, right?
It's just 1.
Which is just 1, that's right. Now what's nice again is just like the other one, this had a hole at negative 2, right? Doesn't have a hole anymore. So the way you apply a one-sided limit is the exact same way you apply a two-sided limit. Just plug in the number. Does that make sense? If it's got a hole, you just treat it the same way you did in 2.2. So what can I do with this negative 2 here? Plug it in. So this would be equal to minus 2 plus 3, right? Because I'm going to plug it in right here. So this is equal to 1. Now if this was a little minus sign, you guys agree you use the top function instead? And instead of this simplifying to 1, this would simplify to negative 1? And then, we're going to do 29. 29, 31, 35, I'm sure. Okay, I'll do a couple. We got 5 minutes. I'll give you 5 more minutes. It'll be fine. All right, so in all of these problems, what we're going to be doing is we're going to be using this fact. We're going to be using the fact that the limit...
Oh, there's 2 parts to 17.
Oh, you guys can do the other one. I explained how to do it. So the limit as x approaches 0 of the sine of x over x is equal to 1. Now, if the sine of x is equal to 1 as well, you guys know that its reciprocal would also be equal to 1. I did this as an example in class. That's also equal to 1. So if you have x over the sine of x or a sine of x over x, the biggest thing here is that these two, this expression right here and this expression right here, have to be the same. Does that make sense? So if that says 5x, that better say 5x, right? Okay. And those things have to be going to 0. They have to be the same thing, and they have to be going to 0 if x is going to 0. So they have to go to 0 at the same speed. So if I have this expression here, I'm breaking it apart. So what I'm going to do, I'm going to hold each piece away from each other. So I have x, I have the cosecant of 2x, and I have 1 over the cosine of 5x. Numerator, denominator. Then I'm going to rewrite, remember we're using the sine of x over x, right? So the only thing I care about is the sine function. The reason why I don't care about this cosine function is because when you plug in the cosine of 0, you get 1. So if you look at a unit circle here, this is angle 0, right? And this gives you 1 comma 0. So the cosine is equal to 1. And 1's good on the bottom. The problem is the sine is not, right? So cleaning this up, this is going to be the limit as x approaches 0 of x times 1 over the sine of 2x times 1 over the cosine of 5x. What's the only piece I'm messing with? That one. Is that clear? That the only function I'm messing with is the sine functions? Well, if I have a 2x right here, What do I want on top? A 2x. So if I put a 2x on top here, what must I put on bottom over here? A 2x. Because I have to multiply by 1, right? Okay. What's nice is over here these x's cancel, right? What's this equal to on this part right here? A half, because there's still a 1 on top, right? So this is going to be the limit as x approaches 0 of 1/2 times 2x over the sine of 2x times 1 over the cosine of 5x. The limit, the product is the product of the limit, so I can just take the limit of each one of these things individually. You don't have to write that every time, okay? Yes?
Why did we apply the 2 to just the x and not the cosine?
Because the cosine's not the problem. I can't plug in, like here, I can't plug in 0, right? Because I'm going to have a 0 on the bottom. But it doesn't matter. This, notice how this expression
So
right
we're
here.
just ignoring, you would like if you actually went through the whole thing, you would normally do it because you have to apply it to everything. But since it's just 1, we're not worrying about it.
Yes, that's right. Since the cosine is just 1 on the bottom, we're good, right?
Yeah.
It's like the cosine function is defined at 0. So I don't have to mess with it. But the sine function, 1 over the sine function is not defined at 0. Does that make sense? So like, notice right here, if I was going to plug a number in, if I was to plug in 0, the sine of 0 is 0, right? And the bottom is also, and what are you not allowed to write on my test? 0 over 0. So there's a way to fix that. This 0 over 0 actually simplifies to 1, that its limit is 1. But the cosine function doesn't have that problem, right? The cosine of 0 is 1, and 1 over 1 is 1. That's why I only mess with the sine functions. So now the limit of a half is, well, it's a half because the limit of a constant is itself. What's this piece go to? 1, right? 2x over the sine of 2x is 1. Because remember, it's this. They have the same input, right? Except instead of x's, what are in those locations now? So as long as they match, we're good. So this is a 2x, this is a 2x. As long as they match, it's just equal to 1. And then over here, when you plug it in, this is going to be 1. The cosine of 0 is also 1. So 1/2 times 1 times 1 is a half. All right, got one more. 35 will be perfect. The limit as, I'm just going to write it as x instead of t. Whatever. You know, I'll write it the same way. The limit as t goes to 0 of the sine of 1 minus the cosine of t all over 1 minus the cosine of t. What's it equal to? You guys see that? It's equal to 1. We're done. Notice the expression inside, which is this, is equal to the expression down here, right? You guys see this is the sine of x over x? Now let's make sure, because these two things, these two red things have to be going to 0 if t goes to 0, right? They have to match and they have to be going to 0. So the idea is they have to match because they have to match and they have to go to 0 at the same speed. That's why before I had to make sure that this said 2x over 2x, because they have to go to 0 at the exact same speed. Okay, what happens if I plug in, what happens if you plug in 0 here? What's the cosine of 0? And what's 1 minus 1? So they're both going to 0, aren't they? They're also going to 0 at the exact same speed, aren't they? So this is just like the sine of 5x over 5x, right? It's the exact same expression here, where these things are both going to 0. So this is just 1.